Good morning, everyone. This is the third session of the Technical Masterclass series for ModelOp Centers. And today we'll be doing a hands-on presentation about runtimes and your model. There's two previous sessions that are out there and available as recordings. If you haven't had a chance to view those yet, I highly suggest that you go ahead and review those. They'll give you the overview of the systems in the first one, and the second one covered specifically around our model catalog. Today, our session is going to be very hands-on, and that's going to be the runtimes in your model. So we're actually going to be developing models in Jupyter and in Python that will actually be enabled to work within our runtimes environments today. So I do encourage you to also keep in mind our next sessions where we'll be talking about designing a model lifecycle on Monday, the 18th. And then we've been doing these every Monday, but the Monday after is Memorial Day. So to be respectful of that, we are doing the next one on Wednesday, right immediately following the Monday session on basically integrating ModelOp Center and BI tools. And specifically, we're going to be looking at how we integrate Tableau with our data sources for both test data and KPIs and other things. So that will be a hands-on session about how to design those reports and interact with our system. So that'll be a really good one to attend as well. So I highly suggest you make both of those a priority if you can. And with that, I'm going to only do a couple slides today. This one's all about the code and actually developing model code and what's going on there. So we're going to be doing very little slideware today and mostly that, but I did want to remind people of the overall architecture. This is all running live on a Kubernetes cluster, and we'll specifically be interacting mostly today with model manage around storing the assets and metadata and et cetera, and we'll be using Git for doing that. We'll also be using the Jupyter Notebook and our plugins to be able to modify models in our systems and register new models with our systems on that. And of course, we'll be using the model lifecycle server to actually shepherd that process once we've completed our notebooks, moving it out into production and interfacing with the ticketing system and then running tests and things like that. So we'll be going through those today. So kind of what we'll be doing today. So it'll all be all hands-on. We're going to start in with basically implementing a echo model, kind of like the hello world example there. And that'll be very simple. It's just going to return the record it receives exactly as it receives it. And we're actually going to implement the different functions that are necessary to work with our runtime. Now, keep in mind, we work with multiple different runtimes. We've shown you already Dataiku. We also work with Spark runtimes and other kinds of things as well. But we have our runtime, which is pre-enabled to allow dynamic binding of endpoints without changing any of the model code. So, for example, I can tie the same model code to a Kafka queue, to a RESTful endpoint, to an S3 file, to all different kinds of things, to SQL databases, that kind of thing. So we're going to talk about how we actually orchestrate a model to actually be able to perform with that dynamic endpoint binding. So those are going to be the functions that are begin, score, train, and metrics function, and we'll go over those as we implement the new model, starting with Echo. And then what we're going to do is actually shift from that point, because that's a ridiculously simple example and doesn't, it gives you the raw framework of what a model should look like. But we want to actually take a real sklearn model and implement that model within Jupyter. And we're actually going to associate not only the model file itself, but our model lifecycle allows automated validation of the model as it moves through the process. And that includes things such as adding test data that is associated with the model. Now we're going to be adding it directly into S3 from our Jupyter Notebook. But additionally, we could have that already existing out there in an S3 bucket, et cetera. And then we're also going to look at DMN and specific utilizing decision tables to be able to analyze test results and associating those with the model. So that way we can do more sophisticated comparisons of test results than just one value is greater than that. We can look at ranges, we can look at multiple scores and construct together and return meaningful messages to the reviewer when something goes wrong. And then finally, we're going to be looking at when we put all these pieces together with this real model and have it all there, how do we actually submit that model and have it run through that life cycle and get validated? And what does that overall process look like? So that'll be the thing. As I said, very little slideware, so that's it on the slides on that kind of thing. So we're going to move on to actually the real implementation here on that. Let me just switch screens here real quick on that. And so what we're going to do is we're going to develop this Echo model within utilizing Jupyter Notebooks and Python. So we have our local instance of Jupyter installed here. And with that, we actually have, if you'll recall, extensions that actually allow us to communicate with the ModelOp Center services to make the overall process more automated and easier to do and that kind of thing. So we'll be utilizing those to get the model into the ModelOp Center to be managed as that. So we're going to start out by creating a brand new notebook. So we're going to create a Python 3 notebook. And now we're just going to implement a simple model. We're going to use Pandas, NumPy today as our data manipulation frames, because those ones are always pretty easy to utilize, and the industry standard there will be NP. So we're just going to go ahead and bring in those two libraries there. Move my cursor so I can see what we're doing here. Okay, so again, we're going to start out with those methods we were talking about in the intro there, where we actually can create some standardized methods that allow us to plug into our specific runtime and act in kind of a loose-bound pattern to the data source. So that way that runtime can take care of communicating all the data and abstracting it for us. So we're going to start out here with basically an annotation that basically just says what the function is, that this is the one that's providing initialization. So if you had some code here that you want to run before the model runs, regardless whether it's a scoring or it's a metrics function or a training function, we put that in here. So we're just going to put a stub in there so you get the idea, so we can see how we can actually build that out. And likewise, we also have tags for scoring. So when we want to actually score a record, we can put that same comment here. And the function can actually be named anything we want. We'll scan for that tag and pull it in. And you can actually change these later if you wanted to through the ModelOp Center UI. You can actually go and specify the functions that should be called there, as well as if you wanted to switch them live. So we're just going to print out a simple message there. But now we're actually going to implement our model, which is, again, kind of the hello world, just to echo back the data that we received. And then finally, we're going to create a metrics function where we are going to create some scores for this particular model. So as I said, for this item, it's going to be a really simple, just kind of set of scores. Now, these scores can actually be any kind of a name value pair you want. We particularly recommend JSON to return those in. And we've abstracted that to basically make it a little bit simpler on that. So what we're going to do is just return dictionaries, and they will be converted to JSON automatically. So we're going to go ahead and we'll implement a record count first, just as one of our scores, because obviously we're not predicting anything here, so we can't have a true one. When we do the real model, we'll look at real metrics directly from sklearn that we can expose instead on that. So, but for now, we're just going to implement a simple record count. Change that plural there. And we'll just do ourselves a mean here as well. We'll grab that. We'll use NumPy to that. So we'll iterate on that. We'll just go from the records. We're going to expect floating types. And we'll just go ahead and grab the mean from there. And then all we have to do is yield that dictionary, and that will work out. So we're just going to yield stick, and we'll say total records, record count. And then we'll do also mean. There we go. That's all we really have to do to actually have a basic echo model in here. As I said, the tags provide an automated way to find the particular functions within your model that should be called for these kinds of actions. And then basically the action function would score a single record. And then likewise, the metrics function returns overall any metrics that you want. sklearn and things like that will provide us standard things like F2 and things like that, and we'll show an example of that next. But we're doing the best metrics we can really with an echo example. Now we'll just make sure that actually compiles, and sure enough, that runs just fine. So then we're going to create some test code as well, because typically in a notebook as a pattern, you're going to want to actually be able to not only have your model code in one of your cells, but you're going to have some test code or some play around with the model code or some things like that. So we're going to show how we handle that of separating those kinds of entities. So we're going to have a begin function just to initialize our item if the model required initialization. Then we're going to go ahead and just test out our echo function here. We're going to just create a random series, and then we're going to iterate over that random series. Just type there. And we're just going to go ahead and print out the result for our playing around. Remember that we're using the generator pattern here, as that allows the engine to interact with it dynamically. So you just need to pull on next on that to actually get the item. And then we can go ahead and actually test that and make sure our scoring function is working as performed. Nope, I typed something there. What did I mistype? There we go. I got an extra. All right, so go ahead and run that again. There we go. We can see, in fact, our action function, our scoring function, seems to work fine. Passes in what's there. Then we're going to also go ahead and test our metrics function as well to make sure that that's all good and performing as expected. We could obviously use the same series, but we're going to go ahead and generate a new one. Hang on, I'm going to do the same thing again. Type one too many B's. And we'll go ahead and do that. And this one, the metrics obviously takes an entire series. So we're going to go to the metrics of S and make sure that that actually works. And we'll go ahead and hit run on that. And we can see, in fact, sure enough, our metrics function returns the dictionary we expect with the total record set and the mean value as our scores. So now we've actually created an entire simple model. And you can see in the notebook, we have a mixture of both code that would actually be deployed as the business model, and we have some code that just exercises this, that lets us play with it. You know, maybe we have some additional data items and things like that. So we need to be able to distinguish between those multiple different kinds of code in that. So when we go to actually register a model with the ModelOp Center, we can use our plugin to do that. It's going to ask us to actually specifically select the code cells that should become part of this model. Now, in this case, I'm not going to put this exercise code in there because it's not even really test code. It's just for me to play around with, and I'm not checking the results or anything. So that can stay persisted with the notebook on your notebook server. But meanwhile, we want to make sure we push this code up into the ModelOp Center to be managed and to become the business value that we're providing. So we're going to go ahead and do next. We're going to name this model whatever we want and give it a meaningful description here. We're going to go ahead and actually now tell it that that's the primary source. We're going to give it an actual Python name so we have something to track it by. And now we could actually specify additional attachments if we wanted to. In the next example where we bring on a real full-fledged model, we'll be doing more with that, where we actually go and bring in a decision table and some weight files and some test data, and we'll talk about how we do that process as well. But for now, this model is really simple. We don't need a whole lot in there, so we can go ahead and next. It'll tell us what we're about to do. We'll go ahead and submit that model into ModelOp Center. Now that that model's been submitted, we can go out to the ModelOp Center and see how it's represented out there. So we're going to go to the model screen. We can just go things. We can see our echo demo we just created. And we can see that we have our basic information about it and things like that. So we have that there. Additionally, you can see we have our source code that's associated with the model on there, as well as we get the platform information that was brought in about the development platform that came from the Jupyter plugin. So we have all of that. And we don't have any specific attachments associated with this particular model. So we can do that. So that lets us get it into the system. Now I want to remind you here, we have a model lifecycle for models that actually runs through here. So you can see where once we submit a version, it's going to go through and actually run the test data on the model. It's going to parse those into a standardized test result. It's actually going to create a notification for us in Jira when this model is ready. And it's one of the things we're going to point out we're going to switch to doing a real model here in a second. is that we have the ability to actually analyze the test results using decision tables that are associated with the model. And, it's going to if it doesn't pass that decision table, it's going to reject it and create a JIRA notification. And if it does, then it's going to go on for approval before it ultimately actually goes out to the actual deployment, in this case on one of the engines, on that kind of thing. So before we go in, we've got that model into our system and that's ready to go, but we really want to take a look more in-depth model here about the different items. So now that you've kind of seen the high-level framework of the simplest example of the functions we actually need to implement here, we're going to go ahead and bring in a real model, that kind of things that actually does something useful. So we're going to go ahead and actually create a new Jupyter notebook again here for our new model. And this time I'm not going to make you sit there and wait while I type it all in. So let me bring up my cut and paste stuff right here. So we're actually going to go and grab this particular model that I've already got in here. Now this one is actually a model that will go out and will look at the Enron emails from a public data set that's out there, and it will attempt to predict insider trading based on the language that's contained within the actual emails themselves. This is one we actually showed in a demo earlier in the first series, but now we're going to dive deep into what the actual code looks like and how we enabled it and how it works and how we actually test it and things like that. So you can see here that we actually have a begin function here with our ModelOp init that's actually here, where we actually go in and basically load up the training artifact. And we'll show how that gets in there in a second, as well as making sure that the proper language library is downloaded so that needs to execute before we go. Then we have our scoring function, which is going to score an individual record, but also likewise, we have our metrics function that actually is going through and actually generating real metrics based on the test data that's associated with the model. That basically thing. So we can see here, we're going to be generating an area under curve, we're going to be generating an F2, we're going to be generating an ROC curve, and then we're going to ultimately return them as those dictionaries. So we can just leverage the capabilities of sklearn to generate all of those values for us, and we can dynamically bind the test data through the pattern I'm going to show you, as well as analyzing that test data. And you can also see we have a training function defined in this case. You can actually have ModelOp Center train the items for you if you would like. We're not going to do that today because it would take a bit longer to run, and I don't want to do that. So we're going to actually upload a pre-trained weights files in this case, which is also an option and a very valid pattern to use to actually develop your models within ModelOp if you so desire. So you'll see here that we have code in here. But now what we really want to do is also, we've got our metrics function implemented and we have some idea about how the model should perform. So we want to make sure that there's a kind of a comparator, what we call a test comparator, excuse me, that's actually associated with the model that does these kinds of comparisons. That we also use, from the previous demo, we use Camunda. So, we've got this life cycle here that we implemented with Camunda that's going to do this analyzation, has our extensions and stuff. And in the next class, we will be going through in detail how to build one of these. So we'll dive deeper on that next time, and I highly suggest you attend that one as well. It will really give you kind of that next level idea about how do I actually model my business process and how do I use our extensions and delegates and signals and stuff to go implement those kinds of things. But now we're also going to be using it to look at basically comparators. So basically the idea of being able to specify what actually the ranges the test results should be in. Often you see automated test comparison results where they simply look at something like the accuracy is greater than 90% or something. And, that's not very realistic when we get into the details with these kinds of models. It's usually some level of comparison. Now, this is basically a DMN editor. DMN is an open industry standard, been around for a while, where it's basically kind of XML as a basis, and basically that describes the table. Fortunately, Camunda, in their modeling tool, actually gives us the capability to design these in more of a graphical methodology. So you can see, for here, we're going to keep it fairly simple, just to make it easier to follow along. But basically, we're gonna examine the area under curve and the F2 values to determine if basically the test passes or not. So for each row on here, I can specify a threshold. You can actually specify things like numbers between. You can, we use something that's called the feel expression, which is an extension to DMN that's part of the standard as well, that allows you to put all kinds of different things. Here, we're only going to examine one value at a time, but we could say, for instance, that the AUC is less than 0.9 and the F2 is less than 0.62 or something, and then that would only be triggered if both of those items were true. So you can build up quite a long list where you look at ranges and look at comparative nature between like an F2 and an AUC, because you're going to have things like false positives, false negatives, et cetera, that you want to do those comparisons on. So this lets you do that. Matter of fact, you can easily just add another score to this too as well, so you can do that. And if you leave it blank, it just ignores the score. So you can build these decision tables out pretty easily and expand them as you go along and gain more knowledge. Better yet, you can also say, you can say whether the test passes or not. So if you wanted to put an explicit, it always passes if it meets this criteria, you can do that, or you can do it fails if any one of these values goes down. But more importantly, you can also provide a human readable reason as to why this test should be considered failed. So rather than just something like, and this one is pretty simple, AUC under a threshold of 90, you could provide English language rationale as to why we believe this particular item failed above and beyond just the raw numbers. So you have that capability by using the decision tables as well. And that's all just built into the MLC process that we just showed you. That will automatically do that when we submit this particular model for execution. So with that, we're going to go ahead and grab that XML. Now, we could upload this as an attachment, but I like these things to actually be source code controlled. They're kind of very, very similar to source code assets, in that we want them to actually kind of capture the differences and trace where they go along. So we can do that in Jupyter. Now, obviously, we could directly import this from Git. We have that capability and can bring models from there as well. So you could be using any IDE of your choice. But today, for basically the nature of doing this, we're going to go ahead and just insert another cell, and we can actually just put that that DMN right into another cell. Obviously, we're not going to execute that because it's XML, but by having it there, we actually can create it as an asset within the model that'll be managed when we onboard this model. Now we've got the model here, we've got our DMN. We're going to go ahead and actually onboard this model so we can run through the full life cycle with the model as well. So we're going to go ahead and actually select not only our model source code, but we're going to go ahead and also grab that DMN file as well and do that. And then we can go ahead and we're going to do our, we're going to go ahead and do that. We'll just put a simple in there. And so then it's going to take us through the different cells we selected and ask us to identify what it is. So this is the primary model source that we actually want to run, and we'll call that enron pi3. And then likewise, we're going to take us, and it'll focus now on the DMN. So this is not the model source, obviously. So we're just going to name this one test comparator DMN. And the only important thing is that it's labeled as DMN. When we do this, what we're actually doing is every asset associated with the model also has something called an asset role. We talked a little bit about that in the last session, but based on the extension, we will attempt to guess what role it's providing, and we'll set those. We can actually go and change those in the ModelOp Center UI later, or if you manually bring it on at a later time, you can actually specify specifically the individual file. But to make it easy, we tend to know if you're uploading a DMN file, it's more than likely one of these. So we'll go ahead and set that for you on that kind of thing. The name's not important; it's that role that is what actually determines what function it's going to provide to the overall model and its structure. So now we've done that. Now we're going to add some additional attachments. As I said, we're going to save some time today and not actually train the model. So we're going to go ahead and grab the pickle file that I already trained previously on that kind of things and associate that with the model. Because it's a pickle file, it will also assume that's serving as basically a model weights file or a model serialized file that the model is going to read. And then we're also going to go ahead and add the test data and do that as an attachment. Now, when we add through this interface, it's actually going to take our local file and copy it up into S3 for us and create a remote S3 instance of the file that can be referenced, because obviously it can't read that test data off of our particular laptop. Now, we could also already have test data existing in S3, and instead of actually uploading at this time, we could just point it at that existing test file instead and have that available to us as well. So you could have a central pool of these test files, or maybe leverage a data catalog, or all different kinds of things. When I say S3 files in this case, we refer to these as external file assets. And they don't only have to be S3. We're using S3 in this particular cluster. They can be things like HDFS or other remote file protocols as well. So that we have the test data in there. We have the DMN file in there. We have the the pickle file in there. We have the model source in there. I'm going to go ahead and submit this. We can see there's 2 attachments and 2 assets that we actually hear. And then go ahead and actually submit that model to the ModelOp Center as well. So now that we can go back up here and we can take a look at how we actually imported that. So we can see, in fact, that our new data is actually up there. We have the source files that are here. So we have the model source file. We also have that test comparator that's going to be executed. And additionally, again, we have our platform information, but now we can see our attachments that we added as part of this as well. So we have the pickle file that's associated with the training of the lasso, and we also have that test data so that our model lifecycle can automatically detect that. Because what's going to happen is within our model tool here, when we go execute this, we're going to go actually create that test run. And this process right here is going to go out and actually look automatically for that test data role on the model, grab that, and likewise, this analyzer is going to look for that DMN role, the test comparator role on that DMN file, and use that for this analysis. We're going to go ahead and actually center and get over to the correct screen here. So now we're going to go ahead and basically we can actually submit that model. So we're ready. The model looks good. We've run our tests, etc. We're saying this is ready. So we're going to go ahead and submit that model and click OK. And when we do that, you can see it's starting up the process. Now it's actually running the test. It's utilizing that test data we already uploaded into S3 through that add attachments process. And it's executing the tests and that metrics function using that data to generate the scores that we actually want to look at and analyze the DMN file. Now you can see that actually went out and tried to analyze that data. And in fact, what actually happened, see right here, is it created a JIRA ticket for us in here on that. We can see that item. Oops, looks like I got a failure on there. So basically, it failed on the particular DMN. So let's go see what we actually failed on out here, because our score was less than 0.86. My ticket has not shown up on that. Let's try that again. We got something a little bit went a little bit wrong there. Let me grab the MLC file here and see what happened on that. Okay, we got typo in there. Let me fix that typo on our metrics function. So that will tell us here that, let me over to our first code here. And we mistyped our DMN. So we'll fix our DMN real quick here. So we have F2 score. And our DMN, we actually had F2. So all we have to do is change that, grab that right there. And now we can actually update the model to fix that. So the model will tell us that, in fact, we added those 2 F scores to us. So let's fix that real quick, and we'll resubmit that model. And it will go ahead and do that. And now when we go out here, it should run. We're going to rerun that test real quick. See how we can actually locate and debug things really quick that go wrong there by just looking at the logs there and see what the failure was. is running. Okay, and sure enough, it completed. It attempted to compare those scores, and you'll see where it actually failed that DMN test. So basically, it said that we were out of compliance with that particular range, and it's gone into JIRA and created our ticket for us. So we can see here that, in fact, we got that message back from the decision table that the threshold was under 0.9. Do that. Now, we want to launch over and go take a look at the test result. Actually, we can see that, and we can see, in fact, that the F2 score, the AUC was 0.82, which is, sure enough, that is below the valid threshold for that particular model. So now we can go back and fix the model. Now we're going to cheat a little bit here, and instead of fixing the model, what we're going to do is we're going to change the value in here. Because obviously you don't want to sit here and watch me actually retrain the model and do all that. We're going to go ahead and actually just change that variable so that it's now instead 0.8 instead of the 0.92. We could have done that in the graphical tool here as well. We could just go, change the value right here on that to the 0.80. So that will quote unquote fix the model. But yeah, I said we don't want to go through all the retraining and things like that. So we're gonna just change the criteria by which you succeed, which is always a little bit easier here. So made that change to the notebook. Once again, we're just going to quickly upload the our model to update it. We can see the changes. We can see we're changing the 9 to an 8 on there. I'll go ahead and save that model. And once again, now what we're going to do is we're going to submit that model again. And when we submit the model again, we will see that it's running. It's going to go rerun those tests on that. Again, it's utilizing that test data we added as an attachment, and now it's using that updated DMN. So, the per model item, you can put them up there, they can have that, but you could even have those as external and shared. So if you had criteria that spanned models that you actually need to look at, you could do that as well. So it's a really powerful technique for being able to do that things. And this model lifecycle is independent of the specific one. It'll just grab it from the model itself. So we can see, in fact, this time it passed the test. It's actually going there, and we can basically refresh the issues. We'll see that there's a new review of the model that's there that we want to do that. And, so now we've passed that DMN test, and it says, sure enough, you're good to go. So somebody needs to give this a look over. So we can go ahead now and actually review that test result and see the items that are out there and how it's performed. Now, we could also, on that, so, you have that kind of information available and things like that. We could do some champion challenger comparisons, et cetera, as well, if we have that in place, and things like that, as we showed in the intro demo on how to do all that stuff. But now that we've actually gotten that model and we're happy with it, we've run the live test, so we know that the model is basically functioning, we know that the predictions are working, the data is good, and et cetera. Now we can go ahead and actually mark that model as done. And when we do that, it'll actually go ahead and initiates the process to actually deploy it out on the server running. Now we can go examine actually on the runtime. We can see our model is now deployed out on one of the engines. And in fact, we can see that it's bound to a RESTful endpoint in this particular case. So we didn't have to do anything to make that happen. We could actually switch it to a Kafka as well if we wanted. And then additionally, do a live view where we actually monitor the impact it's having on the system out there. And we can review the full process it actually took to get out there. So, we can see that the tests were run, those were the test results. We can see the actual DMN it used to do the comparison, see the JIRA ticket process, and see who reviewed it, and ultimately ended up out on here. So we have that full lineage from end to end about how the model was initially developed. We can get back to the information about the model itself and see all the assets, resources, and training files and everything that went into this particular model. We can see the overall process it went through to get there, and we have great insight into models as to what went on there and the full kind of capabilities of the system to capture that information. Now, obviously, we only display some of the information that's actually available here. In the class after this next one, so basically the one that will be on Wednesday instead of a Monday because of the holiday, so it'll be early, we're actually going to look at how we can pull even more information out of our system using Tableau. to actually be able to expose different trends over time and KPIs and things like that. So you can see even more about these models that have been deployed and their associated data and tests and things like that. So I really hope you will join us for that, that class as well. And I look forward to talking to you again a week from today about specifically designing model lifecycles. I look forward to that next thing. Thank you for your time today.